Now, first of all, let's go one by one and understand what Hadoop is. The core, as I said, Hadoop has a lot of things, a lot of tools you can add. And as we go along the course, we will keep on adding tools. But the two main components are file system, right? Because you need to store data. The data which I put into a Hadoop system, or let's say any box, Linux box, Windows box, I need a file system to store it, right? And I need some logic to process that data, right? I need some programming model to process that data. So we have two parts. One, file system, which is called HDFS. H stands for Hadoop. DFS has come from, which I have shown you the history, distributed file system. So it becomes Hadoop distributed file system. MapReduce is the programming model, right? So now let me ask you, I told you some statement, right? I said Hadoop is a file system which we need on any system, right? Linux, Windows, whatever. Can anybody tell me why we need a file system? Can't we write data without a file system? Why we need a file system? Right, so many of you might have installed operating systems and all, and before the operating system is installed, it first formats your hard drive, lays out a file system, and then installs on top of it. But do you think file system is mandatory to write data? Rohit Kulkarni is saying store data, read whenever we need. Okay, okay. Ronak is saying for faster retrieval. Okay, okay. So we have 2 points. Rohit is saying store data and read it whenever we need. So Ronak is saying for faster retrieval. Okay, I think those two answers we have. So let me give you a little bit background on this, or the history of how all these things came into picture. Right? Let's say I have a hard drive. First of all, if I want to write a data, I do not need a file system. Right? You might be saying what I'm saying, right? We do not need a file system to write data. But let's say if I do not lay out a file system on a hard drive, I write something, how will I find out where it went? Right? Let's say I have a book, I have an index of a book, right? I may have all the data in the book, but if I want to find it, I have to go by index. Okay, book is a very small example. I can just go through the pages, but on the disk, how will you find where the data went? So file system is very important from a read perspective, from a faster retrieval perspective. We can write data without a file system. Many systems do that. SAN does not have file IO, it does block IO. For example, there are many people in the audience who are from system background. Whenever we configure a crash dump is a process. Whenever a running system crashes, it writes the content of a memory to a predefined location on the disk. Solaris, OpenVMS is doing it beautifully, used to do it beautifully. It is still there. Let's say on a hard drive, I define some sectors, some location, right? And I'm running a system with 32 gigabytes of memory. System is up and running. All of a sudden system crashes. Can it write 32 GB of data in few fractions of second before the system goes down? How I can make sure it does not go through the overheads of my file system? So what we do is we predefine the location. We say to the Linux kernel or a Solaris kernel or a VMS kernel that you just dump at this location. It bypasses the file system, dumps it, but when we need to read it, we know where it was, which locations it went. We'll go there and read it, right? So now Hadoop HDFS is also simply a file system. Now let's look a little bit deeper into it, right? Before understanding Hadoop HDFS, let's go a little bit into the traditional file system. How a disk is laid out and how data is stored. Any system, whether it's a Linux, Windows box, right? I have a hard drive in a system. I will partition it. I will format it. I will install an operating system, write some data, right? So it will have a master boot record, which is called MBR, right? Which will tell me kind of a structure, which will tell me, okay, where all my partitions are. I will have a file allocation table, which we called as similar to index of a book, which will tell me that file 1 went to these blocks. Inodes is a term which is used in the Unix world, Unix Linux world. In the word of window, we called it as file allocation table. Inode means the same thing. So it's a data structure or pointers which point saying this particular file is on these locations, right? So this is how it points. Let's say I have a file music.mp3. It says it is on inode 23456. So I will have some metadata. Metadata means the MAC time, right? Modification, access, and creation time, timestamps, who is the owner, permissions, size, and where the actual contents of the file are. It will be pointing to hard drive, right? Now, what is the difference here? In Linux, Windows, whatever systems you have, your this metadata, which is telling you where the blocks are, and the metadata itself, they sit on the same node, right? They sit on the same node. So data and metadata of a file system will sit on the same disk, right? Not even just same box. Let's say if my system has 3 hard drives, each hard drive will have its own metadata, its own super blocks, unless and until obviously they are not in a RAID, right? They will have their own metadata and data, which will sit within the same disk. But in Hadoop, this differs a little bit. In Hadoop, what we do, instead of having data and metadata both on the same node on a same disk, what we do, we have given a separate node to a metadata. It stores the entire metadata on one node, and your actual data goes on some another nodes. We call them slave node. So the name node is called the master node, which will store all your metadata, and your data node will be called your slave node, which will actually store your data, right? So let me explain you this, how it will be. Let's clear the screen. Shiva is asking 3 disks, 3 metadatas, or metadata depends upon the number of file systems. Okay, yeah, so that's correct, right? So obviously, so what Shiva is saying, I use the statement that if we have 3 disks, it means 3 metadata. Not necessarily, right? I may have a one disk which I have partitioned, right? Let's say I have a Windows partition, right? And I have C drive, D drive. I will have a common super block, but I will have a fat file allocation table for each partition, right? So it will be multiple. It can be more than the number of disks, right? Or the number of the file systems we have. Okay, now coming to the Hadoop part. So what is a metadata first of all? Let's say even in Linux, when I say a file, let's say file1.txt, how the metadata will be? It will be saying who is the owner of the file, what are the permissions of the file, right? And timestamp, and then it will point me to the blocks of the file, right? This is what metadata is, right? So now, in as I said, traditionally everything was sitting in one node, one particular file system on the same system. But now what happens? This metadata, which says, let's say I write a file to Hadoop, it will say file1.txt, whose owner is XYZ, whose permissions are this is the timestamp, and this is the size, has block B1, block B2, block B3, right? It will tell me what blocks are mapped to it, right? What blocks are mapped to it, right? Let's say file f1.txt. It will tell me all these parameters, owners, permissions, time, size also, right? There's one size also. It will tell me all these things here, right? And there will be one more thing it will tell, which I will tell you later, which is called replication, right? It will also tell me something called how many times each block is replicated, right? So it will having a R factor here, but it will say B1, B2, B3, and where B1, B2, B3 will be, they will be on slave nodes. Where will be block B1? It may be on data node 1. B2 may be on data node 2. B3 might be again on data node 2, right? Right? All these will be on one meta node. So this is what we will be understanding in the slide. So let me explain you one by one what it is. Metadata will reside in the memory of the name node, like any other system. Let's say on a Linux or a Windows box or any other box, if I need to work on a file or a process on a file, it must be in the memory. I cannot work on a file which is sitting in a secondary storage like disk. It has to be brought into the memory either by a DMA call, which is direct memory access controller call, or some other mechanism, but it must be in the memory. So what is happening? The entire metadata of my Hadoop cluster will be handled by my master node, which is name node, and it will sit in the main memory of the name node, right? It will never be swapped out to the disk. It will never be swapped out of the disk. When I shut down my name node, it will be persisted to disk, similar to any other database concept. For example, I'm running MySQL. It will have a bin log. The moment you keep on writing, it goes into bin log. After some times, it does a checkpointing, writes into a database or commits into a database. Similar thing NameNode does. So NameNode also maintains a journal, right? Which we called it as kind of an edits file, right? So today I'm just giving you a kind of an introduction, a glimpse of things. From tomorrow onwards, we will take one thing at a time and see all the technicalities into it, right? All the details into it, right? But let's, as a building point, start point, let me explain you things one by one. Now, I said name node will store the entire metadata in the memory of itself, right? Name node, entire metadata will be sitting there. Obviously, now how big my metadata could be? Obviously, limiting factor will be the memory I have on my name node, right? RAM, the amount of RAM on I have on my master node will decide how big my cluster will be, right? Quite interesting thing. Can I have 10 nodes, 100 nodes, 1000 nodes? Will be decided by the memory on the name node, right? So I will give you this of a kind of an assignment for homework for you. I will at the end of today's session, and we will talk in detail about this, right? What does this mean? So now let's say if I have 4 gigabytes of memory, on the name node, obviously I cannot go beyond it because I cannot swap my metadata onto a disk. So my cluster will not go beyond that. It cannot have more files than what my name node can store in the memory, for what metadata it can store in the memory, right? So now what is happening, whenever we write anything to Hadoop cluster similar to any database, first of all it goes into a journal file called edits, right? All these details we will see tomorrow, and it will be committed to another file called fs image, which is file system image. So what happens, whenever we write anything, any changes, they go to a journal file edits, and edits will commit to a file called fs image on the disk, right? How it will commit, when it will commit, lot of concepts are behind that, right? But for the time being, it will commit to the disk, and when it starts back, it will read the fs image file, and it will know what all files I have. No. Another thing, important thing which I mentioned in the explanation which I gave in the last slide, last means last whiteboard, I said what NameNode will tell. NameNode will say, I have a file whose name is file1.txt, owner, permission, timestamp, size, replication, and it will say an array. It will say, I have a list of blocks B1, B2, B7, any block. It will say this file is on these blocks, and this is persisted to disk in fs image. Whenever we shut down a name node, and there's a concept called checkpointing. Whenever checkpointing happens, edits journal will be emptied, and it will be written to a disk, on the disk hard drive, in a file called fs image, right? But now the question comes, NameNode is saying this file has blocks B1, but how it knows block B1 is on which data node, right? Let's say I have a name node and I have data node D1, D2, these are all data node, right? Now in the metadata, this metadata which it has, it nowhere says anything about data node. It is only saying it is B1, B2, B3 block. So to handle this, NameNode has a second kind of a metadata. So NameNode has two metadata. One is file metadata, this one. Second metadata is called bitmap. So in the audience, I have people who are from OpenVMS background. So it's the same concept which Hadoop uses. It's called pigeonhole bitmap, right? So what it will do, there will be another metadata which will map the blocks to data node. It will say B1 is on D1, B2 is on D2, and B7 is on D3, for example. So there will be two metadata, 1, 2, right? So this is what we are explaining here. So metadata is, one is list of files, list of blocks for each file, then list of data nodes for each block, file attributes and access time. Correct? So now what it is telling me, I have a block B1 for this file, but where is B1? It is on D1. B2 is on D2. B7 is on D3. And the interesting thing is, this metadata, bitmap which I am talking about, it is only in the memory of the name node. Only in the memory of the name node. It is never persisted to disk. What does it mean? If I shut down my master, shut down my name node, this thing, right? This thing, it will go to disk. It knows that. But which blocks map to which data node, it will not know. It will wait for data nodes to advertise to it, right? So what happens? I have a name node and I have data nodes, right? So data node will have a daemon which is called data node daemon. So we will all see. So name node will have a daemon called name node daemon, right? A process running. Data node will have a daemon, a process running called data node daemon. Whenever a data node starts, it advertises all the blocks it has. Let's say I have 1 terabyte disk divided by the block size, n number of blocks. So data node 1 will say I have n number of blocks. Data node 2 will say I have n1 block, n1 number of block, n2 number of blocks. Name node will now know what is the capacity of my cluster, and it builds the bitmap dynamically. So b1 it will map, it will say okay, b1 I have got from d1, now I map it. So this is called block report. Block report is maintained by data node, the slave side, and every time it boots up, it sends the block rate report to the master saying these blocks I have. And on the name node, when it is receiving the blocks, it is just building this map. It is saying, oh, I have got b1, oh, it is coming from d1, let's build my map. b2, oh, it's coming from d7, let's build my map. So it builds the map, right? So now lot of details in this also, right? We will see this as we go in the session. We will be, as I told you, few people joined late. So what things we are talking in theory, it's not just on the slides. I don't believe in those things. We will be looking at each thing practically on a box. When I say you that name node stores metadata, so I should prove it to you. I should not just say it, right? How will I make you understand that it is true, right? So if I say name node stores metadata and actual data goes to data node, right? For example, as in the slide, metadata will be saying this file has these blocks, and these blocks are on data node, right? Let's see. Let's write to Hadoop, right? So for the time being, don't worry about how we have set up Hadoop. We will be starting a Hadoop setup and all from tomorrow's class. But let me give you a feel of the things we do, right? So now I will try to explain you the concept which we have discussed in theory, that metadata is on a master, actual data goes on data node, how we are setting it and all